Hi. Last lecture we have discussed about hazards, that is logic gates with delays and some two-level logic circuits and all. Okay, up to now. Now let us see the next one. We'll see a few more problems after the end of the chapter. Now let us see the next topic in this, that is K-maps. In the Boolean algebra and K-maps chapter, the next part is K-map. Why we use K-map already why we use K-map is basically to minimize the function, same as like Boolean algebra. But before going to K-map, we should have some basic about min terms, max terms, SOP, POS representation. What is SOP? What is POS? What is min term? What is max term? What is canonical form? All these basics are required before going to the K-map. Let us start with that. Okay. Now understand first. See here. Suppose I have a function a, b. It can be 0, 0, 0, 1, 1, 0, 1, 1. When you have two variables, you have four possibilities for the inputs. And output can be anything depending on your requirements. Say for example, it is like this. Then how can I specify my function? Say this is my function. How to say about this function? If I ask you to define this function, I can define in two ways. My one method you generally say is my output is first time 0, next time 1, next time 1, next time 0. This is one method, but you understand that is not required. In output, you have two possibilities, 0 and 1. Okay, if you mention your output is 1 for these kind of inputs, it is okay. Because by default, if for these inputs it is 1, remaining inputs, what is the output? We can expect it as 0. Similarly, you can express the output is 0 for these two cases. What is the meaning? For remaining two cases, output is 1. You can specify your function either using zeros or by using ones. Your output 0, it may be any manner you can take according to your function. Your output function may be 0, 0, 1, 1, 0, 1, 1, 1, 0, anything it can be. So if you are specifying your function with the help of ones, then it is called SOP. If you are specifying your function with the help of zeros, it is called POS. How to specify with the help of ones? Simple logic. Say for example, give numbering here 0, 1, 2, 3. In a general way, in the English statement, you can say we can say like this: my output is 1 for input 1 and 2, or you can say output is 0 for input. What are the inputs? 0 and 3. When the input is 0 or 3, output is 0. When the input is 1 or 2, your output is 1. You can say in this way or in this way. If you express your function in this way, it is given a name SOP. What we call it as a sum of product. If you express using this, then it is called POS, product of sum. It is sum of product terms. It is a product of some terms. Why that name? Okay, you understand here. What is the meaning of this POS? Here, first understand this. Output is 0 for the inputs either 0 or 3. That is, if A and B are 0, 0 occurs or 1, 1 occurs. If any one of them has occurred, my output should be 0. Okay, similarly here, if any one of them occurs, my output should be 1. Okay. That is, your input is 0, 1 or 1, 0. Any one of them is 1, your output should be 1. Okay. Any one of them is 1, then it is 1. Then what is the meaning of this? It is nothing but OR operation of these two cases. OR operation means a sum. That's why it is sum of products. Similarly here, if any one of them is 0, your output should be 0. So any one of them 0, output is 0. This is the function of AND gate. In AND gate, any one of them is 0, output is 0. That's why it is AND operation of sum terms, that is product of sum. I'll explain again with the help of example. Just write down sum of product is also, first keep the heading SOP and POS. Keep the heading SOP and POS. SOP and POS. Write down. SOP is also called as, there is another name for this. SOP is also called as, write down this, disjunctive normal form. Because if examiner give you, do it in disjunctive normal form, you should not be confused. Okay. Similarly, another way is POS. Okay. POS is called conjunctive normal form. Okay. First write down. SOP is also called as disjunctive normal form. POS is also called as conjunctive normal form. Please write these two lines. SOP is also called as disjunctive normal form. POS is also called as conjunctive normal form. Conjunctive normal form. After that, just another name for this. Okay, another one is canonical SOP. I will explain what is canonical form next. Okay, canonical SOP is also called disjunctive canonical form. Similarly, canonical POS called conjunctive canonical form. Please copy these two also. Don't copy the table. Please wait. First copy this one. Canonical SOP, canonical POS. Okay, write down. Write down next line. SOP is a way of expressing the function. SOP is a way of expressing the function with the SOP is a way of expressing the function with the help of ones in the output. With the help of ones in the output. Next line. POS is a way of expressing the function with zeros in the output. POS is a way of expressing the function with zeros in the output. Please take this example, copy this. So you can understand fundamentally what is SOP, POS. These are nothing but way to express your function. Two ways to express your function are SOP or POS. What is SOP? when the output is equal to 1, we are saying. When you say when the output is equal to 1 in your function, indirectly you are saying zeros also. You need not specify again. Similarly, you can say with the help of when the output is equal to 0 also. When the output is 0, you are saying, indirectly you are saying for the remaining cases your output is 1. Okay, because your output in this Boolean case is only two possibilities, either 0 or 1 only. Copy. Okay. Now, keep the side heading min terms and max terms. Next heading min terms and max terms. With the help of example, I will explain what is min terms, what is max term. Please understand. Min terms will say one second. Min terms will specify the condition for the output should be 1 when this particular input, say here for example A and B are 0 0. Whenever A and B are 0 0, whenever A and B are 0 0, I want my output to be 1. I want my system output to be 1. For that, what is the input you should give? That is given by min terms. So whenever A and 0 are 0 0, my output should be 1. What is the condition required for this? I should give the expression as A bar B bar, because 0 bar is how much? 1 into 0 bar. What is the answer? 1 into 1 is 1. Okay. Only, please understand, you may ask me, sir, can I take directly A bar because 1 plus anything is 1? This min term should be unique. This min term should indicate only this condition, not any other condition. Okay. So what is this min term is indicating? It is indicating the expression required to get 1 when A and B are 0 0. Is it clear? The expression required to get 1 in the output when A and B are 0 0. That is 0 bar 0 bar. Similarly here, how to get 1 when A and B are 0 1? 0 bar is 1 into 1, that is A bar B. Next, here 1 into 0 bar, that is B bar. Here 1 into 1 is 1, so I should give AB. So these are called minterms 0, minterm 1, minterm 2 and minterm 3. My output is 1. Whenever AB is 0, 0, the expression required is A bar, B bar. 0, 1, expression required to get 1 is A bar, B. What is the meaning of to get 1 means? This line will tell the condition required to get output 1 when A and B are 0, 1, not for remaining condition. This condition should be unique. It should indicate only one condition. Similarly, max terms will indicate zeros. That is, what are the values of AB required to get 0 in the output? What are the max terms required to get 0 in the output? See here, AB, 0, 0. When A and B both are zeros, how to get 0? Can I say 0 into 0? Then it is wrong. 0 into 0 is 0. Not only for this, there are so many cases where you get 0 into 1 also 0. So don't take here product. Suppose if I take A plus B here, let me check. A is 0, B is 0. So what is 0 plus 0? 0. So it is A plus B. This is the condition unique for AB 0, 0. When A and B both are zeros, how to get output may 0? When A and B both are zeros, then it will indicate that output should be 0. It is given by A plus B. So similarly here, A plus B bar. Or indirectly you can understand it is indicating if it is 1, you will get bar in the expression. If it is 0, you don't get bar in the expression. So 0 plus 1 bar is 0. 1 plus 1 bar plus 0. 1 bar plus 1 bar. These are the conditions which represent the output should be 0 when these particular inputs will occur. These are called as max terms and these are called as min terms. Is it clear? Min terms will indicate the expression required to get 1 in the output. Max terms will indicate the expression required to get 0 in the output for this particular input condition. Okay. Expression required to get 1 in the output for particular input combination. What about this? To get 0 in the output. Okay. What is the expression required? Same as this, but here to get 0. That is the definition or meaning of your min terms and max terms. Now let us take one function, how these min terms and max terms will be useful for me. Let me take one example. My output is like this. Randomly I have taken. My output is 0, 1, 1, 0. Okay. For this particular combination of AB 0, 0, 0, 1, 1, 0, 1, 1. Now here what I want to say is for this how to write output expression for this function using SOP and using POS. SOP take the help of min terms. POS will take the help of max terms because SOP is with the help of to get 1 in the output. POS will express with the help of zeros in the output. So you can understand here. You can say this function in two ways as we discussed earlier. It should be 0 for this and this. Okay. If A and B are 0, 0 or A and B 1, 1. When AB is 0, 0 or 1, 1, any one of them happens, your output should be equal to 0. What is the meaning? If either this occurs, any one of them occurs, what is the condition required? My output should be equal to 0. If any one of them is 0, output is 0 means what is the operation we should take? AND operation. So you can see here your output is AND symbol is like this, product of max terms 0 and 3. Okay. Or it is equal to A plus B into A bar plus B bar. This is how we write the expression. or you can write the function as it should be 1 for this case or this case. If any one of them occurs, output should be 1. So if any one of them is 1, output is 1. It is called OR operation, represented by sum of m means here minterms, here max terms. Sum of the minterms. Which minterms? Minterms 1 and 2. That is, minterm 1 is what? A bar B or A B bar. This is the expression in SOP and this is expression in POS for this particular function, or you can check this function is nothing but exclusive OR gate. Okay, we got the same. If you expand this, you get the same again. Okay, or you can understand here this is the XOR gate in the POS and SOP. Both represent same function. Very, very important point. Please remember, SOP, POS both are not complementary. SOP, POS both are not complementary. Both represent same function in two different ways. SOP, POS both are representing two functions in two different ways. Both are indicating the same function. Okay, you can solve this, you get this, or you can expand this, you will get it. Both are indicating the same function in two different ways. According, or you can say it is a AND OR function, it is OR AND function. This is NOR, this is NAND. So according to our convenience, we may take POS or we may take SOP according to the availability of your gates and all. Okay. You can also understand here, these terms are complementary. Suppose if you have 1, 2 here, you always get other than 1, 2. If you have 0, 3 here, you always get other than 0, 3. These terms, okay, that is min terms, max terms are always complementary. But SOP, POS is not complementary. Very important. Because min terms representing 1, max terms are representing 0, they are definitely complementary. You take complement of this, you get this. If you take complement of this, you get this. Min terms, max terms are complementary. Okay, here whatever you have in the max, you don't get it in the min. But functions both are same. So SOP, POS represents same function in two different ways. They are not complementary. Min terms and max terms are complementary. Okay, clear? So further understanding, if you want, you see what is this function. This function is representing my output is 1 for either A bar B or A B bar. That is, if your input is 0 1 or 1 0, both the cases my output is 1. That is indicated by this. Here my output is 0 for A plus B. That is here 0 0 or sorry, my output is 0 for A plus B, 0 0 or 1 1. So any one of them is 0, my output is 0. What is this function? That's why we have taken AND operation. If this is 0 or this is 0, any one of them is 0, my output should be 0. So AND of any one of them 0, output is 0 means AND operation. Any one of them 1, output is 1 means OR operation. That's why here product, here sum. Okay. That is about SOP and POS. Please copy it. Blindly how to write it means, in the min terms 0 means bar, 1 means no bar. Max terms 0 means no bar, 1 means bar will come. This is a blind way to remember, but you should understand the facts behind that. Blind way is 0 means you will get a bar, 1 means you don't get bar in the SOP. POS mein 0 means you don't get bar, 1 means you get the bar. Okay, SOP takes ones, POS takes zeros. Copy it. Okay. Now keep this editing. Properties of SOP and POS. Right. First point. Write on the first point. With n variables, there are 2 power n minterms, 2 power n minterms and 2 power n maxterms are possible. With n variables, there are 2 power n minterms and 2 power n maxterms are possible. Okay. You can observe here how many variables I have taken. 2 variables. 2 variables A and B. So 2 power 2 is how much? 4 minterms are possible. 4 maxterms are possible here. Or you can say 4 combinations are possible. 2 power 2. If you have 3 variables, 2 power 3 minterms, 2 power 3 maxterms. 8 minterms and 8 maxterms are possible. Okay, write down next. Let us take one, make a note for understanding purpose. Minterm corresponding to binary 0 1 0, that is binary 0 1 0, m2 is equal to, just for understanding blindly how to say, when it is minterm mein 0 means we take bar, 1 means we don't take bar. Minterm corresponding to the binary 0 1 0, m2 is a bar b c bar, just for example. Okay, next write down. Maxterm corresponding to the binary number 1 0, means input mein 1 0 1. What is 1 0 1 means? 5. So maxterm 5 if you have 3 variables. Okay, is, if it is minterms, 0 means bar, 1 means no bar. For maxterms, what is the relation? 1 means bar, 0 means no bar but take plus, 1 means take bar. This is how we write minterms and maxterms for any input combination. If it is 0 1 0, a bar b c bar, 1 0 1 for maxterm, a bar plus b plus c bar. Okay, copy it. Right. Second point. Second point. Minterms, one second. Write down like this. Minterm I is complement to maxterm I and vice versa. What is the relation between minterms and maxterms? I already given. Minterms and maxterms are complementary to each other. For example, if you take minterm 2, what is minterm 2? 0 1 0 means a bar b c bar. What is complement? What is maxterm 2, for example? 0 1 0 means, I am taking 3 variables. Okay, 0 1 0. 0 means here no bar. 1 means you have bar. 0 means no bar. So what is the complement of minterm 2 bar? What is a bar b c bar whole bar? You take a complement means first dual and complement each variable. Then what is the answer? A plus B bar plus C. You see, A plus B bar plus C, it is exactly same as max term 2. So min term 2 bar is max term 2. Max term 2 bar will be min term 2. Like that, min terms and max terms are always complementary to each other. You can check here also. You take the complement of this, you get this. You take complement of this, you get this. So min terms, max terms are complementary to each other. Copy it. Right. Next, third point. Min term I and max term 2 power n minus 1 minus I are dual to each other. Min term I and max term 2 power n minus 1 minus I must be dual to each other. Okay. This point you remember, you can use this logic for finding self-dual expression. Suppose in any function, the min term I, okay, and min term 2 power n minus 1 minus I are same I will show you later, then it will be self-dual. Or this first understand this condition properly. If min term I is always dual to max term 2 power n minus 1 minus I. What is this 2 power n minus 1 minus I? Let us take one example. N equal to 3 variable function. N is the number of variables A, B, C. Okay. Let us take I is equal to 2. So what is min term I? Min term 2 is equal to, what is 2? 0, 1, 0. Just now we discussed A bar, B, C bar. Next, what is max term 2 power n minus 1 minus I? That is max term 2 power n, 2 power n, that is 2 power 3. Okay, minus 1 minus I. What is I here? 2. So max term 2 power 3 is 8. 8 minus 1, 7. 7 minus 2, 5. So min term, take its dual. 5 means what? 1, 0, 1. What is 1, 0, 1? 1 means here I should take bar plus max term mein plus. Okay, 0 means no bar. 1 means we should take bar. Take dual of this function. A bar into B into C bar. Is it same as the A bar into B into C bar? Min term 2 or not? So this is the relation always satisfied. What is the relation will be always satisfied? Min term I and max term 2 power n minus 1 minus I dual, both are same. It is vice versa also. You can take dual on other side also, you will get this. So min term I, max term 2 power n minus 1 minus I is always dual to each other. Copy this. You can use this logic for finding the number of self-dual expressions. I have given earlier as a homework to find in an n variable function how to find number of self-dual expressions. For that you can use this. This logic can be helpful in that as a hint. last point in this. Fourth point, sum of all the minterms is always equal to 1. Sum product of all max terms is always equal to 0. Pi means here product. You can understand sum of all the minterms. What is the meaning of sum of all the minterms? Whenever your function is 1 for all input combinations, when your function is 1 for all input combinations, then sum of all minterms is, what is that function? It is always 1, we can say. Suppose your function is 0 for all input combinations, then you can say the function is blindly 0. As always, sum of all minterms is 1, sum of product of all max terms is 0. You can take that example. For example, you take n equal to 2. So sigma I equal to 0 to 2 power 2, 4, 4 minus 1, 3, minterm I is equal to how much? Minterm 0 plus 1 plus 2 plus 3. Take all minterms. A bar, B bar plus, A B bar plus, sorry, A bar B plus, A B bar plus, A B. Take A bar common here, B bar plus B. A common here, B bar plus B. A bar into B bar plus B is 1. A into B bar plus B is 1. What is A bar plus A? 1. Sum of all minterms is equal to 1. Product of all max terms is always equal to 0. Copy it. Okay. So these are the properties of your minterms and max terms. Now, see here. The next one in this, we use one more term, canonical SOP, canonical POS. Let us see that. For example, I have AB bar, A bar C, AB. Some function is there, randomly I have taken. Generally here A, B, C, it is a 3 variable function. Yes or no? A, B, C 3 variable function. But in this, it is a sum of product terms. I can say it is a SOP. Say another function, A bar, B bar, C, A, B bar, C bar, A, B, C. For example, this function is there. We call this as, it is also sum of product terms only. We call it as canonical SOP. What is the difference, sir? Here you can understand, if you observe, if it is a function f of A, B, C, if all product terms are containing all the variables, whether it is in normal or complement, doesn't matter. If all variables are present in each term, then it is called as canonical form. Similarly, if you have A plus B into A bar plus B bar into, please don't copy, A plus B bar. Some function is there like this. This is POS, product of some terms, but it is not canonical. Then what is canonical? Every product here, every term should contain all the variables of your function. They can be normal or complement, doesn't matter. It is then this is called canonical representation of POS. Say if this is given, SOP is given, how to convert into canonical, or POS is given, how to convert into canonical, I will give you. First write down, understand the difference between SOP, canonical SOP. You can understand SOP is a sum of products simply. Canonical SOP is also SOP, but in the canonical SOP or canonical POS also, every term should contain all the variables either in the normal or in the complement. Every term, whether it is a product term or some term, doesn't matter. That term should contain every variable. Whatever variables you have in the function, it can be 4 variable, 3 variable, 2 variable function. If it is a 3 variable function, all the 3 variables should present. If it is a 2 variable function, all 2 variables should present. Write down that point first. Keep the side heading canonical form. Canonical form. Canonical form. In the canonical form, each term must contains all the variables. Each term must contain all the variables in either normal or complementary form. Each term must contain all the variables in either normal or complementary form. So if it is 3 variable, this is correct. If it is a 4 variable, I should get all the 4 variables in each term. Okay. So each term should contain all the variables in the normal or complementary form. Okay. Please copy these examples.